Good morning to all.
Good morning, sir.
Good morning, sir.
Good morning, sir.
Today we
morning,
need
sir.
to
Good
learn
morning, sir.
string constraints.
Yes, sir.
Right. Before we proceed, just one small problem to remind us of what we have done in the previous class. If I have a mass of 10 kg here connected by a string to a mass of 5 kg, what will be the acceleration of both the masses? Rather, relation between their velocities, then the acceleration, so on and so forth. First of all, the tension in this string will be T, the tension in this string will be T. Tension will always act away from a point with respect to the point. Tension will always act away from a point with respect to the point. This is acceleration A, this is acceleration A. Today's class, this is what we will learn. How are you deciding that both will have the same acceleration? How are you deciding that both will have the same acceleration? Temporarily, I'm telling you they are two ends of the same string. If this string has an acceleration of A, this string will have an acceleration of A. This is what I'm telling you temporarily. If it is a complicated version, how do you get the relation between their velocities and acceleration is what we will learn in today's class. Now, what is the free body diagram for this? This is T, this is 5G. Vector summation of all the forces on it is equal to mass into acceleration. 5G minus T is 5 into A. First equation, is it clear to all?
Yes,
Yes,
sir.
sir.
Yes.
Second equation, horizontal forces, there is only one force tension, 10 into A. Horizontal forces on 10 kg block, only one force called tension, 10 into A. Before I start simplification, I will verify if number of equations is equal to the number of variables. Two equations and two variables. Add both, I'll get 5G is equal to 15A. G by 3 meter per second square is the acceleration of these both. If you ask me for tension, it will be 10 into G by 3. 10 G by 3 Newton is the tension in the string. Simple, straight head, elementary, what we have learned in the previous class, just reminding you people of it using an example. Take it down till here. Can I rub the board?
Yes, sir.
Yes, sir.
Listen. Suppose I tell you this is a string. Length of this string should remain constant. If the length of this string should remain constant, this end moves by a distance of x1, this end moves by a distance of x2. In the same time interval. This end moves by a distance of x1, this end moves by a distance of x2 in the same time interval. What will be the elongation in the string?
0.
X1 minus x2
Minus x2,
will be
yes,
the
sir.
elongation in the string. If this end moved by a distance of x1, this end moved by a distance of x2, elongation in the string will be x1 minus x2. Do you agree with this?
Yes, sir.
Yes, sir.
All of you convinced?
Yes.
I want this elongation to be 0 because the length of the string is constant.
Constant.
x1 is equal to x2. dx1 by dt is equal to dx2 by dt, which implies v1 is equal to it.
Yes,
Something very simple.
Yes, sir.
Yes, sir.
Now, when things become complicated, we tell the students to look at it one way. You stand at the center. If this end is moving away from you, it will be plus x1. This end is moving towards you, it is minus x2. This is contributing to increase in length. This is contributing to decrease in length.
Yes, sir.
Yes, sir.
Yes.
For instance, if this end moves to the right by x1 and this end moves to the left by x2.
Along
Both
X1
contribute
plus
to
x2.
x2.
Now, what will be your constraint relation? Plus x1 plus x2 should be equal to 0. How will both of them move out and no elongation here? Both moving out is wrong. The constraint will take care of itself. You will get x1 is equal to minus x2. v1 is equal to minus v2. Both of them cannot be in the directions that they are. One of them will have to change the direction. If v1 is positive, v2 should be negative. Reverse the direction. Right? So the constraint will take care of itself. So always remember, from the center of the segment, if this is moving away, it is contributing to increase. Put plus x1. From the center of the segment, if it is moving away, it is contributing to increase. Put it in plus x2. This is the net total elongation of the string. String should not have any elongation. So equate it to 0.
0.
Sir, sign conventions of vectors are not used here. Right is positive, left is negative. That
You are taking with respect to the center. Don't take with
Oh.
respect to another origin, with respect to the center. If it is
Okay.
moving away, it is contributing to increase in length. This is increase in length and decrease in length.
yes, sir, got it.
So the x1 and x2 in this case is only the magnitude of the force, right?
Right. We showed the arrow that shows the direction. Take it down till here. I will take an example and explain the same.
Sir, x1 and x2 is the distance, right? Not the force.
Distance move. Right. That's what even the other student said. He said it's a magnitude. Matlab distance ही तो है.
So I think he said magnitude of force.
Force. Constraint. Constraint dictionary meaning is restriction. One will restrict the movement of the other using a string. Hello?
So, sir, practically in the second case, both x1 and x2 aren't contributing to the increase in the length, right? Because upon putting the conditions, they become opposite.
Right.
Sir, they are going in opposite directions. So how do they become like, how do they cancel off each other? Because like,
That's why you are getting a negative sign. So both cannot be in the direction shown. One of them should be reversed.
oh, okay, okay.
This is one mass and this is one mass. This is M1 and M2. This is technically called Atwood's machine. This is technically called Atwood's machine. Simple pulley in your language. How to write the dynamic equation, how to calculate the acceleration, everything will come to in the next class. Right now, I want the relation between the velocities of these two masses. What do I want?
Relation between
Relation
velocities
between
of
velocities of the
masses.
mass.
Now listen, first I'll tell you how do we apply, then I'll tell you the science behind it. Let me assume this going up by a distance of x1, this endpoint moving by a distance of x2. This endpoint is not moving, this endpoint is not moving. First, you will have to decide distances moved by endpoints of each segment of the string. For a string, there are two segments. One segment is this, one segment is this. Every segment's endpoints moment I should know. Every segment's endpoint moment I should know. I assume, if I don't know, I'll assume a value. I took x1 here. How do you know it is in the upward direction here? I don't know. It depends on the mass m1 and m2. You change the ratio, it will be in the reverse.
Yes.
Sir, can I assume any particular direction? Take a direction, stick to it and solve till the end of the problem. If final acceleration you get positive, direction taken is correct. Final acceleration you get negative, reverse the direction. Right? I can stick, but once you assume a particular direction till the end of the problem, stick to the same direction. In between, don't change.
Yes.
This is segment 1, this is segment 2. This length of the string is constant, that cannot change.
Yeah.
Now this end is not moving, it is 0. This end is not moving, it is 0. Segment 1. This end point is moving towards the center of the segment. Is it contributing to decrease or increase?
Decrease.
Decrease.
Minus x1. Are you convinced?
Yes.
Yes, sir.
Upper end point is 0. Are you convinced?
Yes.
Yes,
Sir.
sir.
Yes.
This end point for segment 2 is 0.
Yes.
Yes, sir.
From the center, this end point is moving away from the center of the segment. Is it contributing to increase or decrease?
Increase.
Plus x.
Plus x2. Sum total elongation of the string I will equate it to 0. x1 is equal to x2. v1 is equal to v2. Obviously magnitudes. Directions you are able to see there in the opposite direction.
Yes.
Yes.
Right? v1
Yes,
is
sir.
equal to v2. Now, science behind it, concentrate. Only once I'll explain this. Thereafter, we'll be using this directly. Observe this carefully. This was your original problem.
Yes, sir.
Yes.
Yes.
If m1 moved up by a distance of x1 and m2 moved down by a distance of x2. Now observe this carefully. There are three segments in this. One segment is the length along this. Did not change, it is pi r.
Yes.
Did not change, it is pi r. Now, the string towards the left of the pulley, length decreased by how much? x1. See this length decreased by x1. I'll put it as minus x1.
Yeah.
This length did not change. Put it as
Constant.
zero. The right string to the right, its length increased by how much?
X2.
X2.
Total elongation, you equated it to 0. x1 is equal to x2, v1 is equal to v2. This string on the pulley, its length did not change. This string's length decreased by x1. String to the left of the pulley, length decreased by x1. To the right, length increased by x2. Increased length I'll put plus, decreased length I'm putting minus. Sum total elongation I'll equate it to 0. This is what we will keep using regularly, but the science behind is that. Is this convincing?
Yes, sir. Yes.
Yes.
Take it down till here.
Sir,
Hmm.
sir, over here, could we have done something like assumed from the point 0 where you have marked 0 on the left hand side diagram to M1? We can take that
Yes, sir.
take that to be a length x, and then the other one will be the total length of the
That's a
string minus
different
x.
procedure of constraint. We will go one after one. This procedure let everyone learn
Okay,
properly.
sir.
Then we'll deal with it. Differentiating the total and equating it to 0.
Yes,
That is
sir. We can.
originally the most primitive way. When we learned it that way.
Okay, sir.
Sir, what will happen when M2 will come completely down? So M1 will rise to the maximum height. What will that height would be?
There are n number of things about that. Right now, don't worry about it. Get the relation between M1 and M2. There will be a sudden jerk in M2. You hold M2, you hold and release M2. All conditions will come step by step. Can I rub the board?
Yes, sir.
Now I need the relation between x1 and x2. I assume this is going up and this is going down. My assumption is abstract that going up and going down will depend on the masses. Change the
Yes.
ratio of the masses anytime that will get reversed. Right? So you take a stance, solve the problem. At the end of the problem, you will get the result. If it is positive, fine. Now, how many segments do I have? Segment 1,
Three.
segment 2, segment 3. This end is fixed. First of all, are you able to see all the 3 segments?
Yes.
Yes, sir.
Yes, sir.
Now, this end of the segment is moving by a distance of x1. This end is moving by 0. This end is moving by 0. See, this length of the segment will remain constant. It is one single string. Lower end moves down by x2, upper end will move down by x2. Do you agree with that?
Yes.
Yes.
Upper end is going down by x2, whole of the pulley is going down by x2. Whole of the pulley is going down by x2. So both the end points will go down by x2. right? And how did you define x2? Because of this end. Lower end is going by x2, upper end will go down by x2. This length of the string should remain constant.
Yes.
Segment 1,
Sir,
Minus x
Minus x.
Minus
Minus
x1.
x1.
minus x1
minus x1.
plus 0 plus 0
Segment 2,
Plus x2.
plus x2
plus x2
plus x2. Segment 3,
plus 0 plus
plus
x.
0
Plus
plus
x1.
x2
plus 0 plus x2
sum total elongation must be
0.
0
x1 is equal to v1 is equal to
2v.
2v. Now, just as I explained the concept in the previous case, I'll explain this concept even here. Please observe this for once. Thereafter, I will not be dealing with that. This was M1, this was M2. This was the initial stage. Final stage, I will show M1 moving up by a distance of x1 and the pulley moving down by a distance of x2. M2 moved down by x2. That means this end point moved down by x2, this end point moved down by x2. Do you agree with this?
Yes.
Red color is the pulley after time t. Small m2 came down by x2 means pulley came down by x2. This end point came down by x2, this end point came down by x2. Segment 1, segment 2, segment 3. Segment 1 minus x1. Segment 2 plus x2. Segment 3 plus x2. Sum total should be 0. x1 is equal to 2x2.
yes
सर इस फिगर में मतलब M1 से होते हुए ऊपर के पुली से घुमा के नीचे के पुली से घुमा के वापस ऊपर के पुली पे एक ही स्ट्रिंग लगाया है ना, मतलब वो एक ही पूरा
It is the
स्ट्रिंग है ना?
same string.
ओके सर.
If not, I cannot apply constraint. What is constraint? Length of one particular string is constant. Though different strings ka length I cannot apply constraints. One single complete string. Just as I'm telling you, two strings के लिए I cannot put constraints. Half a string के लिए भी apply नहीं कर पाऊंगा. पूरा length of the string should remain constant.
sir, sir, here also we have taken the assumption that the pulley is massless, right? The second pulley which is moving.
What has that got to do with this?
No, sir, because if they add mass, then we'll have to change it.
Why?
So maybe because of that, the velocity will change.
Bullet velocity.
Only acceleration will change,
Yeah,
ना?
acceleration
Because of
sir,
that.
will change. Bullet velocity change.
Yeah.
Even changes V2 also change.
Okay, sir, okay.
Observe this carefully and solve. From next problem you will be solving. I'll just be sitting.
Sir, I didn't understand how the string is attached to the M2 part.
Don't know how to answer. It is attached. How it is attached? Means it is attached.
No, sir. How the same string is attached to the pulley and the M2 part itself?
M2 पे दूसरी string है, दूसरी string है
अरे
M2 पे.
This string, how will it be the same string as that? क्या पूछ रहे हो आप? नींद में हो. This string is one string. I am dealing with constraint for this string. Because this is a single string, this x2 and this x2 will be the same. Two ends of one string.
Okay, sir.
Tell me when I can rub the board.
So segment 3 is different from the total length of the string of segment 1 and 2. So how can we apply its elongation along with 1 and 2?
Wait, repeat your statement.
So segment 3 is different from the total length of the string in segment 1 and 2, like the entire string over there. So how can we apply that constraint for?
Segment 3 is one part of this string. What makes you say it is totally different? This string goes this way, comes over this way, and comes over this way. Length of 3 need not be equal to length of 2. ये किसने बोल दिया? Tomorrow I will have a pulley like this. Segment 1 is lesser than segment 2. Then you tell me V1 is not equal to V2. Segment 1 length and segment 2 length. How much they are initially makes no difference for me. Yet V1 will be equal to V2. Distance moved in time dt and distance moved in time dt will be equal.
सर ये तो चेंज है ना, मतलब इनिशियल से फर्क कोई नहीं पड़ता.
That's what dx1 distance moved. Length of the string 3, segment 3 has got nothing to do with the length of segment 2. Segment 3 is one end is fixed, the other end is not fixed. It is going down. Have a look at this diagram. Segment 3, this end is going down. Can I rub the board?
Yes, sir.
Yes, sir.
Find the relation between V1 and V2. Find the relation between V1 and V2.
Sir, the string is same, no?
I leave it to your fine judgment. If you see different strings, consider different strings. If it is the same string, see whatever you see.
Sir, is that the second pulley being fixed to a place that
This pulley will be moving. What is it fixed?
the other end of the string, like you draw a line?
Sir, can you repeat the question?
Find relation between V1 and V2.
Sir, do we have to send it on the chat?
No, don't. Don't type the answers. Wait a minute. Listen, this is one single string. If the lower end moves by V2 downwards, upper end also will move down by V.
Yes.
Add X2. I'll call it X2 temporarily. Call it X2. This is X1. This step, is it clear to all?
Yes.
Yes.
Now segment 1, segment 2, segment 3 of one single string. Is this clear to all?
Yes, sir.
Segment 1 upper end is fixed, lower end is approaching the center. Plus or
Minus X1.
Negative X1.
segment 2 upper end is fixed, lower end is moving away from the
Plus
center.
Plus X2.
X2.
Segment 3 upper end is fixed, lower end is moving away from the
Plus
center.
Plus X2.
This is the constraint elongation for one complete string, which must be equal to
0.
x1 is equal to 2x2, v1 is equal to 2v.
Yes.
सर अगर सेकंड सेगमेंट के अलोंग वो M2 वाले पुली को फ्लिप कर देते तो पिछला क्वेश्चन ही मिल जाता ना मतलब।
ये क्वेश्चन करो मैं इन लोगों को काहे को कंफ्यूज करते हो लोगों को जिन्हें भी can I rub the board?
सर कंस्ट्रेंट
No,
जीरो
sir.
क्यों होगा?
Constraint
जीरो क्यों होगा?
अरे सिंगल स्ट्रिंग है तो
total
कांस्टेंट है
elongation.
ना।
अब समझ में आया? तू फ्लिप कर रहे हो कुछ पर फ्लिप कर दोगे बच्चे पूछ रहे हैं जीरो क्यों इक्वेट करना है?
सॉरी सर।
This is the total length of the string. Length of the string का elongation. I should equate it to how much?
0.
0. Length of the string will remain constant.
अच्छा ओके सर.
Elongation should be equated to 0.
Sir, V1 is equal to 2V2. So even A1 will be 2A2, right?
Temporarily, yes. There will be an exception for it. I'll come to it later. That's why I'm
Okay,
stopping at V1.
So for now, A1 we can
Yes.
assume. Okay.
Yes.
Okay.
Shall we take this to be going up or down?
Up.
Up.
X1.
Down.
Down.
Now, ironically, you don't know the distance moved by the pulley. You have to assume a particular value. पुली का आपको पता नहीं है. Now, if somebody tells me this end is moving down by x2, pulley will move down by x2 ille. It was for one complete string. One end moves, other end moves by the same distance. You cannot apply it to one segment of the string. You cannot apply it to one segment of the string. Pulley is moving by some distance which you will have to find out. To help you people solve, I'll temporarily take this to be moving down by y. Y is a variable which we introduced, we'll have to eliminate. I want relation between x1 and x2. Y मुझे नहीं चाहिए. I want relation between x1 and x2. Think carefully and so. There are two strings here in the play. There are two strings here in the play. Two strings, so you will have two equations and hence you will eliminate y. Listen. This is segment 1, segment 2 of one string. Do you all agree with that?
Yes.
Yes, sir.
Segment 1 upper end is fixed, lower end is moving towards the center of the segment. What do you want me to write?
X1 plus
Minus x1.
Minus x1. Segment 2 upper end is fixed, lower end is moving away from the center of the segment.
plus y
Plus y.
equals
All should be equal to
0.
0.
y is equal to
X1.
x1.
first equation. Now come to segment 1, segment 2. थोड़ा ध्यान से सुनिए. Segment 1, lower end is fixed. Upper end is approaching the center of the segment.
Minus y.
Minus y.
Segment 2 में both ends are moving.
Yes.
Upper end is also moving, lower end is also moving. Now students tell me, both are in the downward direction. Take either plus or minus for both. One is moving towards the center of the segment.
Minus
Plus
y.
y plus x.
One is moving
Yeah,
towards
positive.
Y plus
the
x.
center of the segment. Both are moving downwards. You are not doing vector addition here. You are verifying if they are contributing to the length of the segment or contributing to the decrease in the length. Increase or decrease in the length. This is minus y. This is plus x. This is minus y. This is plus x2. x2 is equal to 2y. This is my second equation. This is my first equation.
X2 equal to 2x.
So x2 is equal to 2x1. v2 is equal to 2v1. So far, so good. Right?
Yes.
Yes, sir.
Can I rub the board?
So 1 minute.
Sir, how did you get minus x1 plus y?
x1 is moving towards the center of segment 1.
Yes, sir, minus x1. But how y?
Y is moving away from the center of the segment 2.
Won't it be 2y like?
This string, upper end is fixed, lower end is moving away from the center of the segment.
By y?
By
We
y.
assume that. So that's what we
We
assume.
assumed all of this pulley is going down by y.
Okay, okay, sir.
अच्छा लगता है ना यार?
Yes, sir.
हाँ,
बहुत ज्यादा. Yes, sir.
Okay.
Okay, sir. Yes, sir.
This pulley is fixed. This pulley is not fixed. This pulley is fixed. This pulley is not fixed. And this is fixed. You obviously can make a guess. What would be the next question?
Sir, one more pulley
Both
which
pulleys
is
are
not
moving.
fixed.
अरे नहीं,
Another not.
यहाँ fix निकाल के M3 लगा दूँ. That will also be moving.
हाँ.
That is the next question. Then I'll ask you relation between x1, x2, x3. This is the way life goes. पूरा मेहनत करवाऊंगा, पसीने छूटेंगे सारे कंस्ट्रेंट सीखने के लिए. लास्ट में एक ऐसा शॉर्टकट बताऊंगा कि एक स्टेप में सारे कंस्ट्रेंट्स आ जाए। तो पहले क्यों नहीं बताओगे यार? नहीं बताने का, दैट्स द वे इट गोस। I have no choice in changing the way of life. Life goes that way. You have to learn the regular constraints. Only then the shortcut will be taught. Actually, this question is similar to the previous.
Yes.
Almost the same, sir, if we can
Yes,
say.
sir.
Let's make this horizontal. But for that, why I did it is because next step I should put M3 here.
Sir, over here, like in the previous cases, acceleration was coming out to be the same. Here, it won't be same, right?
It will be this. Somebody typed V1 equal to V2, V1 equal to V2 is wrong. See, the police distance moved, I don't know. I take it as y. Before I start the problem, I should know the distance moved by every end point of a segment. Right? This end point I have taken as y. Now this is segment 1, segment 2 of one single string. Segment 1, segment 2 of one single string. Do you agree with that?
Yes, sir.
Yes. Segment 1 upper end is fixed, lower end is moving away by a distance of x2.
X2, yes, sir.
Upper end is moving towards the center of the segment.
Minus y.
Minus y.
Y equal to x2 is my first equation.
Yes.
Segment 1 and segment 2. Segment 1, left end is fixed, right end is moving, plus y. Left end is fixed, right end is moving, plus y.
Yes, sir.
Yes.
Segment 2, right end is moving by a distance of plus y, left end is moving by a distance of minus x1. This is moving towards the center of the segment minus. This is moving away from the center of the segment, put it as plus. This is not moving, I put it as 0. This is moving away from the center of the segment, I put it as plus y. 2y is equal to x1. 2x2 is equal to x1. 2v2 is equal to v1. Somebody type it 2v2 is equal to minus v1. Unless you have taken the reverse direction, you will not get that.
Sir, you are saying the answer on the co-host or host?
I don't know. I think host.
सर
हम्म।
सर मैंने M1 को Y से मूव मतलब मैंने M1 को कंसीडर किया कि मतलब वो सिर्फ Y से और X1 से मूव कर रहा है मतलब मेरा इक्वेशन मैंने लिखा है -x1 + y इज इक्वल्स टू 0 और x2 को मैंने y/2 से मतलब मूव
नहीं,
किया तो
नहीं, बिल्कुल नहीं. You have to take the total length of this string and equate it to 0. That means you are missing this segment.
ओके
This pulley goes ahead. This length increased by y. That is a part of that string only. You cannot take y is equal to x1.
ओके सर
Total length of the string should remain constant. Length of one segment of the string, I cannot take it to be constant. I will not give the same problem by placing M3 here. I'll slightly change that. I'll make it vertical. Can I rub the board?
Yes, sir.
Because I want you people to do it from scratch again. This needs practice. Five meter per second. 2 meter per second. V0 meter per second. Find V0. I don't know if I have given feasible numbers or not, but I think you will get. Don't worry. Find V0. There is a very wise saying. When the going gets tough, the tough get going. और मोहम्मद क्लास में नहीं है.
हूँ ना सर, आज हूँ.
डर लग रहा था. कोटेशन बोलने के बाद मुझे लगा कहीं सर ने बोला गेट गोइंग बंद करके चला गया तो.
नहीं नहीं सर, नहीं सर, हूँ यहाँ.
Sir, wait.
Yes, sir. One
Yes,
minute.
sir. 1 minute. Yes, sir.
Yes, sir. Yes, sir.
Let me say, assume this is going down by y.
Yes, sir.
Segment 1, segment 2. Segment 1 का constraint बताइए.
Minus x1
Minus
plus y
x1
is
plus
equal to
minus
0.
x1
plus
नंबर दिया हुआ
Yes,
था
sir.
x1 क्यों minus 5 plus y
minus
Yes,
5 plus y
y
equal
plus
to
y
0.
is equal to 0.
Y equals to 5 meters.
Y is equal to 5. Yes.
So far,
So
So
good.
good.
So good.
segment 1, segment 2. Segment 1, upper end is approaching the center.
Minus
Minus 5.
5.
Minus
Minus 2.
Minus 2.
Minus 2.
Minus 2. Segment 2, upper end is approaching
Minus
Minus
1.
y.
Y
Plus v naught.
plus V
Plus
naught.
V naught. Yes, sir.
V naught should be 0.
0.
This is 5. Y is 5. 5,
Minus 12.
5, 10, minus
Minus
12
12.
plus V naught is 0. V naught is 12 meters per second. I got positive. That means direction taken is
Downward. Downward.
correct.
Right.
correct
Direction taken is correct.
Right.
Correct.
Correct. Sir, but the displacement of the second pull is downwards, right? But it will not affect the sir, the displacement means the length of the string, sir. Means
Length
I'm
of the
saying that
string constant रहेगा. पुली ऊपर जाए नीचे जाए. This will go down. This will go up after some time. Pulley may be like this. I am making adjustment in the diagram. Is that okay?
yes, sir.
Yes, sir.
After some time, the dotted line is this, right? This went up, this went down. The pulley came down. So this length decreased by my y2 minus y minus 2 is the distance by which this length decreased. This length increased by how much? V naught minus.
Sir, but why can't we take it to be 0, sir? Means instead of y, sir, why can't we it be 0?
The pulley is not fixed.
Down.
How will you take it to 0? वो pulley move कर रहे हैं. Pulley नीचे आए कि नहीं तो ये length का क्या करोगे? छोड़ दोगे?
So displacement of pulley will be y, sir, but that of the string, sir, it why can't we take it 0?
पुली भी तो नीचे आएगा.
This total length decreased by y and 2. This went up by 2, this went down by y2. Length of this side of the string decreased by how much? Y
Yes,
plus
sir,
2.
y, sir. Okay, yes, sir, got it.
Yes, sir.
Yes, sir.
Fine.
V
The
naught.
relation between V1 and V2.
No. Fine.
V naught.
V naught.
Not.
So that first pulley is fixed now.
Yeah, the first pulley is fixed to this table. These three pulleys are moving. Wait, if you typed it as 5 by 4, I don't know the answer, I will solve. Shall I?
Yes.
Yes, sir.
Yes, sir, done.
Let me take this to be going down by y1. y1 क्यों ला रहे हो यार आप बीच में? Because there is y2 as well.
Y2.
Yes.
Yes, sir.
Every endpoint of the string, I should know by what distance it is moved. If I don't
Yes,
know, take a variable and eliminate. Every endpoint of the string. Now, इस पुली के लिए नहीं लोगे y3? नहीं,
लेना
इस पुली
पड़ेगा।
का मुझे पता है. The lower end is moving by V0. This will move down by V0. This will be V0. This will be V0. So I didn't introduce y3. This point till here, is it clear to all?
Yes, sir.
Yes, sir.
Yes, sir, yes.
We start from here, segment 1, segment 2, segment 3 of one single string. आप constraints एक string के लिए apply करोगे. Segment 1 is -10.
Plus 5.
Segment 2 is plus y1. Segment
Plus
3
5.
plus y1. 10 is equal to 2y1. y1 is equal to 5. Till here, is it clear to all?
Yes, sir.
Yes, sir.
Sure.
Yes, sir.
Yes, sir.
Wonderful. Now I come to segment 1 and segment 2 of this second string. Segment 1 minus y1
Plus y.
segment 2 plus y2. Segment 1 minus y1 segment 2 plus y2. Right? y2 is moving away from the center of the segment. y1 is moving towards the center of the segment. Segment 2, 0. The other
Y2.
end plus y2.
Y2.
Sum total should be 0. Second string ka constraint, all of you verify. I am repeating it. Upper end is moving towards the center of the segment. Minus y1.
Yes, sir.
Lower end is moving away from the center of the segment. Plus y2. Upper end is moving towards the center of the segment. No, upper end is not moving.
Fixed.
0. Lower end is moving away from the center of the segment plus y2. Sum total is 0. y1 is 2y2. y1 is 5. 2y2. So y2 is equal to 5 by 2. Now comes the detail. Segment 1, segment 2 of this particular string. Segment 1, upper end is approaching the center by a distance of
Minus y.
Minus.
lower end is
V0.
moving away from the center of the segment plus V0.
V0. Yes.
Segment 2, upper end is fixed.
Plus V.
Lower end
Plus
is
Plus
moving
V0.
away from the center of the segment plus V0. Sum total is 0. When you are telling me segment 2 upper end is fixed, lower end is moving away, you are calculating the increase in length of this segment. Hence, you are taking with respect to the center of the segment. Sum total should be 0. y2 is 2v0 is equal to 5 by 2. v0 is equal to 5 by 4 meters per second.
So does it just get halved for each pulley?
Yeah, it does. To see, It is human by nature that we try to judge people, judge a subject, judge a topic, so on and so forth. A human weakness. It is human. It has got nothing to do with one person. You or me, all of us fall into the trap.
Yes, sir.
One of the student types, kinematics was a bit intuitive here, but intuition doesn't help much. Actually, intuition works. You will have to wait till the shortcut is stopped. Actually, intuition works. Don't judge a subject that way. It is human nature. I also do that. It's easier to preach. It's human nature. But don't judge. Wait till the shortcut is stopped. You will change your mind. And every topic I told you already, you are going through this graph. This will be rotational dynamics.
Rotational dynamics.
You have come somewhere till here now. I'm getting you mentally prepared to climb the ladder. Things will rotation mein dekhoge, rolling visualization will be the toughest. Right? So don't come to conclusions, don't jump to conclusions. Relax. Enjoy the learning process. That's it.
Yes.
2 दिन का जिंदगी है यार, live it, enjoy. These moments you should remember. I enjoyed it. That's it. Right? Ultimately, all of you know that in 5 million years from now, Earth will be gobbled into sun. You are aware of it.
Yes, sir.
Yes,
sir.
Sun another 5 million years from then will explode. So each one of us, after say, you people say 100 years, I after 50 years, let us assume 100, will go back into Earth. Earth will go back into the sun. Sun will explode. Finally, we are again hydrogen and helium atoms into the space searching for a new galaxy or a star.
Yes, sir.
Right?
Yes, sir.
Live your moment right now. Enjoy this. What next? Dekha jaye. Don't worry.
So I had a doubt in this.
Hydrogen and helium atoms.
No, so this question.
Bolo.
So when we assume y1 and y2, so on the left side, when the string goes down, so that's contributing to the increase, right? So that
See, if that y1 is moving away from the center of the segment, it is plus. Towards the center of that segment. For example, let me take this segment.
No, so my doubt was that if the one end is contributing to the increase, so shouldn't the the right side one contribute to the decrease? So we should take it like up.
Renee, so
By
which one you
taking
want?
the reference as the center of the section.
This one?
Yes, sir.
Now have a look. For this segment, what is the elongation? 0 and plus y1?
Yes, sir.
For this segment, 0 and plus y1. Whole of the pulley is going down now here.
Okay, sir.
So this segment increased by y1.
Okay.
Now 1 second, stay online. Don't jump away, please wait. Please wait. This assignment was sent to you already today morning before we started the class. Are you able to see that?
Yes, sir.
Yes, sir.
So
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. You will solve up to the 14th question. I have not taught you 15th, 16th and on. Right? There you will have to resolve. Theta comes into picture. I have not taught you that in today's class. So homework is up to
14th
question. Homework is up to
14.
and all of you have your booklet with you.
Yes, sir.
Yes, sir.
You go to page number 210. Page 210.
Yes, sir.
What do you see? Find the relation between you and me, you and we, problems
Yes,
and
sir.
constraints, right?
Yes, sir.
yes, sir.
First question 2. Third question, third way. First question 2. Third question, third way. In the sense, in that exercise of 1, 2 and 3 questions, leave the last problem that is on constraint. That's on wedge constraints. Did
Sir,
you
can
people
you-
listen to the homework?
Yes, sir.
Yes, sir.
You told us to leave is the one that
Booklet homework.
two triangles, right?
Can you repeat the booklet homework?
Yes, sir. Even I.
Yes, sir.
See this page.
Yes, sir.
Thank you, sir.
Booklet, page number 210. This is the first page, page 210. Are you able to see this?
Yes,
Did you
sir.
get that?
sir.
Yes, sir.
That exercise में there are 3 questions with 4 bits in each question. If you turn the page and see. Leave
Yes,
the
sir.
last question, third bit, fourth question छोड़ के बाकी सब करो.
Okay.
Yes, sir.
आई बात समझ में?
Yes.
थर्ड में फोर्थ क्वेश्चन नहीं करना है.
Third में fourth bit. Last question of that constraint relation, that is on
Yes,
wet
sir, yes.
constraints. I'll take 2 more lectures to come till there. See you people in the next class.
Is there any homework?
Bye,
Bye,
sir.
sir.
Thank
Thank you, sir.
Yes, sir. Thank you, sir.
Thank you.